Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Are we alone in the universe, or could there be life on other planets? Could they be creatures like us? A new detection approach is helping make it possible to find out. A team at the University of Bern in Switzerland has developed a system combining a laser ablation ionization mass spectrometer and a microscope that can detect microbe fossils in terrestrial gypsum formations found in Algeria, which indicates that gypsum could preserve life. The new portable system is designed for in situ planetary analysis. It uses a pulse laser to remove a tiny area of a sample, ionize it, then analyze its chemical composition. It offers micron-scale resolution to better detect fossilized microorganisms and trace elements to ultimately identify biogenic materials. Since conditions on Mars are similar to those in which gypsum was formed, during a period billions of years ago when the Mediterranean Sea was cut off from the Atlantic Ocean, the team says their system could be used to detect signatures of life on the red planet. The team's ultimate goal is to deploy their system on space exploration missions devoted to detecting extraterrestrial life. Germany-based industrial technology supplier Bosch is joining forces with Element 6, a developer of synthetic diamond and tungsten carbide supermaterials based in the UK, to establish Bosch Quantum Sensing, a spin-off venture specializing in quantum sensors. This is an extension of the company's existing collaboration that targets magnetic field sensor applications in the biomedical and industrial realms. While Bosch representatives haven't yet released additional details about the venture, they say Element 6 will hold a 25% stake in the new company. Elsewhere in the quantum business sector, Sparrow Quantum, a Denmark-based startup that focuses in single-photon emitters for quantum applications, has secured 21.5 million euros in Series A funding. Officials say the funding will accelerate the company's research and development and expand chip production to ultimately meet the growing demand for photonic quantum hardware and next-generation quantum chips. Diamond is known for its superior thermal and optical characteristics, making it a strong candidate for applications like high-resolution imaging and quantum optics. Now, an international team of researchers led by Hebei University of Technology in China is harnessing those properties to overcome the conventional limitations of diamond-based lasers. In their work, the team combined Diamond's broad spectral transmission range and Raman frequency shift characteristics with the wavelength-independent nature of generating vortex beams, essentially light twisted like a corkscrew. More specifically, the team integrated a simple vortex beam generation approach called off-axis pumping into a traditional diamond Raman oscillator. In doing so, vortex beams could ultimately be generated in first-order and cascaded-order Raman. Diamond-based vortex beams have excellent wavelength versatility and high power scaling abilities, allowing their operational wavelengths to be significantly expanded. The team says their work is a breakthrough for Raman vortex lasers, as it simplifies such beam generation and broadens the potential for future developments in Raman lasers and vortex beam technology. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.